Alright, we're looking at part 2A right now, part 2 out of 6, but I'm just going to be doing the reading strategies and the problem solving. You guys are going to do the review for mastery. I will have a video that goes back over it, but I want you guys to try it first. So let's go ahead and try some of these reading strategies. You guys have hopefully already taken a look at this. So we got some vocabulary here. I'm going to just highlight some words you might want to circle them. We got the word minor arc, we got the word major arc, and the measure of an arc with two adjacent arcs. So what do these things mean? So the first one here, we're talking about the minor arc, which is just this piece inside, whereas the major one goes all the way around the outside through E, F, and then D. So notice that it says DFE, meaning the F is in the middle, whereas the other one is DCE, where it's just the inside. Oh, it's just talking about the angle here. So this arc, these match, no problem. Keep in mind that it would be a full circle right here, and if you were trying to do the major arc on the outside, you got to add that other piece up to 360. That's why it says 360 minus that. Very similarly, when you have more than one arc, for example, a blue arc and a red arc, like I'm color coding them here, if you add those together, you get the total arc. Purple. Easy stuff, right? So let's say the first arc was, I don't know, let's just kind of guess what this is. That looks like it's about 90 degrees. This one maybe more like 30 degrees. So you put those together and you get 120 degrees. Remember that a full circle would have been 360. Something else is kind of cool, if you have this kind of symmetry, some congruence, where you make congruent chords, then you get congruent arcs, and then you get congruent angles. It's kind of cool, like how one set of congruence makes all the other pieces congruent as well. Alright, so let's pull A. Oh, here we go. The measure of central angle is 60 degrees. What is the measure of its minor arc? Well, if we have an angle that's 60 degrees, and it's talking about the minor arc, that's the same thing, so it's just 60 degrees. What will the sum of a central angle's minor arc and major arc be? Ooh, that's kind of interesting. So we got a circle. Here's the minor arc, and then the major arc, and when you put them together, hey look, we made a full circle. A full circle is 360 degrees. Congruent arcs have congruent chords, or congruent central angles, however you want to say it. But congruent arcs have congruent chords. Awesome. So that means that BC and DE are the same. That's kind of cool. Hey, that's kind of helpful to us. Let's figure that out. That means if this is 32 degrees, so is that. Cool. Alright, let's look for DE. DE is the same as the central angle there, so that's pretty easy, 32 degrees. CBE, so CB all the way around to E. So 360 would be a full circle, but we're cutting out these two in the middle, the 65 and 32. So that's going to be 360 minus, well, what's 65 and 32? Well, we put those together, we get 7, 9, so we're going to subtract 97. Which, how much would that be? That would be 263? 263. Cool. Cool, cool, cool. EBD. So EBD. Okay, so that's starting here. That's starting at the E going all the way around to D. So it's everything except the 32. So in other words, we just take the full circle, 360, and subtract 32. So 360 minus 32 should give us 328. There we go. CBD. Man, they're just making us do these major arcs like crazy. That's going the same kind of opposite direction. This time, we're going to start at C, then go to B, and then all the way around to D, which is everything except the 65. So again, we're going to take the full circle, subtract that 65, and see what's left over. And in this case, it is 295. All right, C, A, B. piece of cake because we figured out that this was the same as this, that DAE and CAB were the same, so that's just 32 degrees. That's cool. And CD, oh, they gave us like a super easy one at the end. It's just 65 degrees. Man, they had us do all these hard ones to begin with. Alright, let's jump into the problem solving now, putting these pieces together. First one is a graph. So I'm going to draw a little graph in here. If I go to Tools, is it Tools, Insert, View, Edit, Grid. There we go. Let's draw a grid up on this screen. Visible. Circle D has a center -2, 7. So I need to draw in kind of a line here. Let's call that one axis, and here's another axis. Actually, that's not going to work too well because I need to go all the way down to -7. So I need to make my horizontal axis pretty tall. So -2, -7. So that'd be here. And then it goes down to -7. So we got 1, 2, 3, 4, 5, 6, 7. So there's a center. And it has a radius 7, which means, oh my goodness, it's going to go all the way up to this. And it's going to go out to 5 right there. That's a big circle. Okay, so that's part of our circle. Then it's going to go way over here. What is the measure in degrees of the major arc that passes through the points -2, 0, 5, -7, then -9, -7, which is way over here. So that means we're going all the way around and coming back up here. Now if I were to draw this kind of small scale, it's like we're starting at north and then we're going, which way would this be on a map? That would be east and then to south and then to west and then stopping. So we're doing 3/4 of a circle. Well, that's like 3/4 of 360. Well, each one I know is a right angle. That's 90 and then 90 and then 90 again. So what's 90 times 3? That's 270. There you go. A circle graph is composed of sectors. That's what we call these pieces in here, like this one that I just shaded in. With central angles that measure 3x, 3x, 4x, and 5x. What is the measured degrees of the smallest minor arcs? Okay, so it's composed of the sectors. So that means we got a circle, and it's got 4 of them. 2 small-ish ones, 1 medium, and 1 large. So we got like small, small, medium, and then large. And each of these are going to be 3x and 3x, and then we got a 4x, and then a 5x. And altogether, we know that they add up to a full circle, which would be 360 degrees. So that means that 3x plus 3x plus 4x plus 5x is going to equal 360. So let's see what we got. 3 and 3 is 6, plus 4 is 10, plus another 5 is 15. So that's 15x, 360. If I divide this by 15, how many times does it go in there? Well, let's see. 30 goes into 360, well 60 goes into it 6 times, and that means that 30 goes into it 12 times, so then 15 goes into it 24 times, is that right? Let's double check. 15 times 24, so 5 times 4 is 0, 5 times 2 is 10, plus 2 is 12, I think I'm going to be off here. Oh, maybe not. Then we got 0, and then 240, 360. Okay, so it is, yeah, 24 times. So x equals 24. Now, that being said, let's see what they ask us. They said the smallest minor arcs, which would be these ones, the 3x's. Well, 3 times 24, that's going to be 1272. 72 degrees. Piece of cake. Let's do another one here. Use the following information for numbers 3 and 4. The circle graph shows the results of a survey. Find each of the following. Okay, so here's where it's weird, because you look at this picture. I look at this picture. We all look at this picture, and there's some assumptions we're making. So the first assumption is that a full is 360 degrees. But that's not the language they're talking here. They're talking percents. And when you are talking about a full percentage, that means 100%. So we kind of have some proportions going on here. For example, for measure of arc AB, that would be this piece here. That's 43%. Okay, so 43%, that's 43 out of 100. And we're wondering what kind of angle is that out of 360? So that's like a question mark there. Let's call it x. Now, this is a proportion thing that I can solve. So I'm going to multiply both sides by 360 to simplify this. So I got 360 times 43 divided by 100. Let's see what we would get. Let's do it. 43 divided by 100 times 360. That gives me 154.8. So x equals 154.8. APC is going to be the same thing. So APC, so I'm going from here over to here. That gives me the 43% and the 25%. So let's first add those together. 25 plus 43 is going to be 68. That's quite a bit. So 68%. That means 68 out of 100 would be a full percentage circle, equals how much out of 360 degrees, how much angle. Okay, so it's pretty much the same calculation. Multiply both sides by 360, and let's see what happens. Well, 68 out of 100, so that's 68 divided by 100, and then times 360. We come up with 244.8. So x equals, in this case, 244.8. Awesome. Super awesome. So now we're going to do something similar, but I want to show you some problem solving where maybe you're looking at it not necessarily as an exact calculation, but we can kind of approximate it. So let's see what we got going on here. First, we got these 4 items that represent all the pieces of things that people were eating for lunch, or their favorite lunches. So here's all the lunches put together. Now, how many is that total? Because we would think of this as 360 degrees, but that's not really what it is. And it's not in percentage, it's in lunches. So when we're talking lunches, we need to know the total for all these favorite lunches here. Let's calculate that total. It'd be 108 plus 75 plus 90 plus 54. That's 327. So when we're talking lunches, we're talking 327 is one full group of lunches. So we're going to do this whole setup again with the proportion. And it's asking us about chicken tenders. So chicken tenders would be 75 out of a full circle would be 327. And we want to know what angle is that out of 360. So again, we got the same calculation. We're going to multiply both sides by 360. We get x by itself. So this is going to be 75 divided by 327 times 360. And that gives me 82.56 or 83 degrees. There we go. That was cool. Super cool. The diameter of circle R is 15 units. Diameter. Diameter's 15. Wait, that means that the radius is half of that, which is 7.5. So that means RT right here is 7.5. Cool. HJ is 12. And it's being split. See this perpendicular thing? That means that this piece and this piece get split. So this is 6 and this is 6. Find the length of ST. Okay, so we know that RT is 7.5, all the way from here to here. We could find RS because, here's the cool thing, we just made a right triangle. And in this right triangle, we have 7.5 here. Then we got a 6 there, and we don't know what RS is. Well, RS. Let's figure that out. So I need to do that whole c squared minus b squared square rooted thing, because I got c and b, and that'll give me a, which is in this case RS. Okay, so c squared minus b squared, that's 7.5 squared minus 6 squared, which is 20.25. Then we got to square root that second square root, that number, and we come up with 4.5. Okay, so 4.5 is this, and you might be thinking, oh, the answer is H, but that's not it, because if this is 4.5, the whole thing is 7. That means this other piece has, or 7.5, that means the other piece has to be 3. They were clever. They almost got us on that one. Okay, you guys are going to like this. I'm going to say go ahead and pass on number 7. Start the review for mastery. And we will see you in a minute. I'm going to stop the video right here. You guys can pick it back up once you've spent about 10 minutes on the review for mastery.